Now we are going to solve a question from the momentum and impulse. So here they are mentioned two particles A and B have masses m and 3m respectively. So we can able to mark the diagram. So this is the mass A and it has that m, and this is the mass B and this is 3m. So the particles are connected by the light inextensible string. So if it is connected, then we need to know the impulse are acting in this direction. So if you are taking the particle A, impulse is like this, and if you are taking the particle B, the impulse is towards this direction if it is connected by the inextensible string. The particle A is then projected along the plane away from B with speed u. So here they are mentioned it is projected away from B with the speed u. But the particle B, the initial distance is not mentioned, because and also we can able to get that initially both the particles are rest, only the particle A is projected, so the initial velocity of that particle B is 0. Given that the common speed of the particle immediately after the string becomes tight is s. So once the string becomes tight, the B is also start moving in the direction of A, because the A is projected away from that B. So the final velocity, it is moving towards the direction of motion of A. It is noted as s in the question. So now the thing is we need to find the s in terms of u. So what we can able to do, we can use the conservation of momentum formula. So that is m1 u1 plus m1 m2 u2 is equal to m1 v1 plus m2 v2. So that m1 means here I am taking that m, and m2 means here I am taking 3m. Okay. So now I need to decide the direction which is that positive for the speed. So I am taking towards left hand side direction of the speeds are positive. So m1 value is m, u1 value is u, so that is positive u because it is towards left hand side. Then plus m2 value is 3m, then u2 value is 0 because it is in initially rest condition. Then m1 value is m1 value is m, then v1 value is s, it is also towards the left hand side, so we can write it as s, then plus 3m times s. So both the particles are moving with the same velocities. Now we can able to write this is mu is equal to 4ms. Now I want that s value, s is equal to mu divided by 4m. So mm get cancelled. Now I can write s is equal to 1 by 4u. This is the s value, so I can write it here, s is equal to 1 by 4u. So now the second part, I need to calculate that magnitude of impulse exerted on A immediately after the string becomes tight. So we can able to use either the A particle or the B particle for identifying the magnitude of the impulse, because both the particles are having the same magnitude of the impulse. So I am taking that particle B for calculating the magnitude of impulse. So particle B, the impulse can be written as the final momentum minus initial momentum. So m2 v2 minus m2 u2, and also I need to describe the direction which is positive. I need to take that left hand side is positive because the impulse towards the left hand side is for that particle B. Impulse acting on that particle B towards left hand side. So the left hand side moving speeds are positive. m2 value is 3m, then v2 value is 1 by 4u. So I can substitute like 1 by 4u, then minus m2 value is 3m, then u2 value is 0. So it is easy to do that because this becomes 0. 3m times 1 by 4u. So this value is 3 by 4 mu. So that is your impulse value. So here we can able to get that answer as 3 by 4 mu for the impulse. So this is the answer for the part B. We need to give that in terms of m and u, the impulse, the magnitude of the impulse.